Hello and welcome to Animated Education. Today we are going to continue talking about derivatives, and we are going to learn what is critical point of a function, what is maximum and minimum, and how to find it. So let's find out what a critical point is. A critical point is such points where derivative of a function is equal to 0 or is non-existent. But to put it in simpler terms, a critical point is where a function was going down and starts going up, okay, in value, or vice versa, going up and starts going down. So this is a critical point, this is a critical point, and this is a critical point. Now, a critical point can be a minimum point or a maximum point, and also a minimum and maximum points can be local or global or absolute, I think. Okay, so this is absolute minimum point, absolute minimum, because as you can see, the function is going somewhere from positive infinity and is decreasing in value until it reaches this point here, and it doesn't go below this point, never, okay? So this is an absolute minimum. Now this is also a critical point, and this is a local maximum, okay? A local maximum, because function was going up and starts going down. Now this is a local minimum, this is a local minimum, because function was going down and starts going up. So now how to find out these local minimums and local maximums? So we need to find a derivative of a function. So let me show you an example. Let's say we have a function f of x that is equal to x cubed minus x. Now there is 3 steps that in order to find maximum and minimum point. First, find the derivative. Find a derivative. A derivative of this function is 3x squared minus 1. The second step is to find when our derivative is equal to 0. So we need to say that 3x squared minus 1 is equal to 0. Now we need to solve this equation, and we get that x squared is equal to 1/3, so x is equal to plus minus 1 over a square root of 3, because I took a square root of both sides. Now I don't like how it is written, so let's multiply it by a square root of 3 divided by a square root of 3, and once we do that we get it like that. That's just a better way to write it, okay, because we don't like a square roots or any roots in our denominator. And the third step is to draw a number line to add these 2 points that we got. There our derivative is equal to 0, and here's what we do. We draw something like this, I don't know how to call it, okay, and this is f prime of x, and this is f of x. So now we need to determine if in these 3 intervals, if our derivative is positive or negative. So let's say we take minus 10, okay, so let's say f prime of minus 10, it will be equal to what? It will be equal to 3 times minus 10 square minus 1, so it will be 29, so it's positive. Now we need to do the same thing with this interval. Let's take 0, okay, it will be easier to calculate. So once you take that, we get that this is equal to minus 1, because instead of x we put 0, and this whole term is 0. And let's take f prime of 10, and it will be also 29, because instead of minus 10 here we have 10 here square, and that is the same thing. Excuse me, I did a mistake here. Okay, I did a mistake. This is not 29, this is 300 minus 1, so it's 299, and this is 299. So this is negative and this is positive. Now if our derivative is positive in that interval, our function is increasing. If our derivative is negative in that interval, our function is decreasing. So we draw arrows like that here, and we get that this is maximum point and this is minimum point. Okay, because our function is increasing and reaches a maximum value, and it starts decreasing, and it's decreasing until it reaches its minimum value. Now let's look at a graph. Okay, so our graph looks like this. So you can see it is increasing until it reaches a point D here, and this is our local maximum. Now it decreases until it reaches our local minimum here, but absolute minimum and absolute global and absolute maximum of the functions is negative and positive infinities. So these points that we find is local maximum and local minimum. Okay, here's another example. F of x is equal to x to the power of 4 minus 8 times x to the power of 2 plus 7. So we need to do all these 3 steps again. So first, find the derivative. A derivative of this will be 4x cubed minus 8 times 2 times x plus 0. So our derivative is 4x cubed minus 16x. Now we need to solve this for 0, and we get that 4x cubed minus 16x is equal to 0. We need to take x before parentheses, and we get that actually 4x, it would be better. So 4x, this will be x squared minus 4, and this is equal to 0. Now we need to apply a formula here, because that's how we solve quadratic equations. So 4x, x minus 2, x plus 2 is equal to 0. Now we can easily find when this is equal to 0. So if we put 0 instead of x, it will be 0. If we put 2 instead of x, it will be 0. And if we put negative 2 instead of x, it will also be 0. So these are solutions to this equation. And the last step, draw a number line. This is f of x, and this is f prime of x, and this is f of x. Now we need to put these points. So here is negative 2, here is 0, and here is 2. Draw these things, these intervals, and let's calculate in these intervals our derivative is positive or negative. So if we take minus 10, for example, okay, so this will be negative, this will be negative, and this will be negative. So in this interval our derivative will be negative, because 3 minuses gives us a minus. Now if we take minus 1 for this interval, minus 1 here, it will be negative, here it will be negative, but here it will be positive. So 2 minuses and 1 plus will give us plus, it's positive. Now if we take 1, it will be positive here, it will be negative here, and it will be positive here. So it's the whole thing will be negative. And if we take, let's say, positive 10 here, it will be positive, it will be positive here, and it will be positive here. So this whole thing is positive. Now let's draw our arrows. A function in this interval is decreasing, increasing, decreasing, and increasing. So this is our minimum, this is our maximum, and this is our minimum. So our x minimum is equal to plus minus 2, and our x maximum is equal to 0. Now let's look at the function. The function looks like this. So it's decreasing from positive infinity, and it's until it reaches a point E at negative 2. This is local minimum. Then it starts increasing until it reaches point H and at 0, and this is local maximum, and it starts decreasing until it reaches local minimum at point G at positive 2, and it again starts increasing until positive infinity. So you can clearly tell that point E and point G is not only local minimums but also an absolute minimums. Okay, one more example. Let's say we have a function f of x that is equal to x to the power of 4 divided by 4 plus 2x cubed divided by 3 minus x square divided by 2 and minus 2x. So now first step, find the derivative. And the derivative will be x cubed, because okay, let me write it a bit more consistently, x 4 minus 1 times 4 divided by 4. Okay, so I'll be doing the same thing here and here. So plus 2x square minus x minus 2. So let me rewrite it, and this will give us x cubed plus 2x square minus x minus 2. Now second step, find the x's when this equation is equal to 0. So is equal to 0 when x cubed minus 2x square minus x minus 2 is equal to 0. Now it's a bit tricky to solve this equation because we need to group our similar terms. Okay, so we will group this and this, and we'll group this and this, because it has 2 here and 2 here, and these both have x. Okay, so once we do that, we get that x times x squared minus 1 plus 2 x squared minus 1. I think I made a mistake somewhere. Yes, it is plus here. So, and this is equal to 0. Now, this term and this term is the same, so we can take it before brackets, before parentheses, and we get x squared minus 1 x plus 2, and this is equal to 0. Now we need to apply a formula here, so we will get x minus 1 x plus 1 x plus 2 is equal to 0. I already said many times how I do this, but basically once you do that, you have to get the same thing if you multiply x by both terms and minus 1 by both terms, okay? So, and you will definitely get the same thing. So now we can simply solve this, and we get that x is 1, x is minus 1, and x is minus 2. You could also write it like that actually, so if it's simpler to you. X minus 1 is equal to 0, x plus 1 is equal to 0, and x plus 2 is equal to 0. And solve all these three equations. But I don't do that because we are dealing with 1s and 2s, and that's, you can do it in your head, okay? At least I think so. Okay, let's continue. So now third step, we draw a line and we put our -2, -1, and 1, draw intervals, and now we need to calculate if our derivative is positive or negative in these intervals. So if we take -10 for example, this will be negative, this will be negative, and this will be negative, so the whole thing will be negative. If we take -1.5, this will be negative, this will be negative, and this will be positive, so the whole thing is positive. Now if we take 0, because 0 is somewhere here, we get that this is negative, this is positive, and this is positive, so the whole thing is negative. And if we take 10 for example, we get that this is positive, 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 so we get that the whole thing is positive. Now our function here is decreasing, here increasing, decreasing, and increasing. So this is a minimum, this is a maximum, and this is a minimum. So our minimum points is -2 and 1, and our maximum points is -1. Now let's look at the graph. So here you can see that this is decreasing from positive infinity until this point here, okay, until point C here, at -2. This is local minimum. It's increasing until here, it's local maximum -1, as we wrote, local maximum, and it's decreasing until point E at 1. This is local minimum and also absolute minimum of that function, and it starts increasing until positive infinity. Okay, so now we have a physics problem, and actually quite complicated physics problem, but okay, here's how it looks. So we have an area, it's a circle, and we have a lamp somewhere here, okay? Oh, I'm terrible at drawing. Okay, so we have a lamp here. This is a lamp, okay? and this is the middle of the circle. This is radius, okay, r, this is height h, and let's call this hypotenuse L. This is a right triangle, and this is some angle alpha. So now we want to put it in such a height h that at this point our lighting would be the best. Okay, so after some math that is not very relevant for us in this tutorial, as we are supposed to learn about derivatives and not physics, we get that our illuminance depends on h as this, okay? This is the square root h square plus r square to the power of 3, okay? So this is a function that determines illuminance on this point, okay, depending on our height. So what we need to, we want to find the maximum of this illuminance. So what we need to do is to apply the knowledge that we got a moment ago. So we need to find a derivative of it. So first step, find the derivative. Now it will be a bit more complicated than the examples I showed you. So this is a constant, okay? Just know that it's some number, okay? R is also 2, we know it, and our variable is h. You can think of it as an x in previous examples, but this time it's h. So we need to find the derivative of this thing, plus r square to the power of 3 divided by 2, because a square root gives us a power of 1/2. So we need to find the derivative of this thing. So let's start. First, we need to apply quotient rule here, because it's division here. So we get that we need to take a derivative of h, multiply it by all this thing, and subtract a derivative of h squared plus r squared to the power of 3/2 times h, and divide this thing by h squared plus r squared to the power of 3 divided by 2 times 2. So these will cancel out and we are left with 3. Now let's continue. We get that this will give us 1. So this will give us 1. So it's h squared plus r squared to the power of 3/2 minus h time. Now to find this derivative, we need to apply chain rule. So we get that 1/2 times h squared plus r squared to the power of 1/2 times a derivative of h squared plus r squared divided by h squared plus r squared to the power of 3. Let's continue. We get that this is equal h squared plus r squared to the power of 3/2 minus h times 1/2 times h squared plus r squared. We can write it as, well, let's leave it as it is. times this, so we can apply some rule here. So this will give us 0 because it's a constant, and this will give us 2h, so 2h, and we divide it by h squared plus r squared to the power of 3. Now these terms, these two will cancel out, and we are left with h squared plus r squared, the power of 3/2, minus h squared times h squared plus r squared to the power of 1/2 divided by h squared plus r squared cube. Now, once we calculated our derivative, we need to find out when all this very complicated looking thing is equal to 0. So step 2, finding then, well, it's not f of x this time, it's e prime of h is equal to 0. So it is equal to 0 when it is equal to 0 when our numerator is equal to 0. So we can left it, our denominator as it is, and don't care about it. So here's what we get. I simply rewrote everything as it was in our numerator, and this is equal to 0. So now, because our h and r is definitely not a 0, because we are dealing with real world problem in physics, we can divide it both sides by this thing. So we are dividing by h squared plus r squared, the power of 1/2. Okay, I'm lacking space here. So once we do that, we get that this cancel out, and this becomes simply h squared plus r squared, the power of 3 divided by 2 minus 1/2. I rewrote this, and is equal to 0. So this will give us 2/2, so it's 1. So we are left with this. And now, well, it's pretty simple to solve this equation. So we get, I made a mistake somewhere. Yeah, I made a mistake here. Okay, I'm very sorry. I'm sorry for this mistake. It's 3 here, so it's also 3 here, and it's 3 here, and it's 3 here, and 3 here. Okay, I'm sorry for this. I'm sorry. So this will give us minus 2h squared plus r squared is equal to 0. So h squared is equal to r squared divided by 2, and we take a square root of both sides, and we get that h is equal to r divided by square root of 2. Now actually it's plus minus here. Okay, let's leave it plus minus here. Okay, but it can't be a negative because, well, a height can't be negative. So we are here with first step, and we put okay, so r is 2. Let's put that number here. R is 2, so this will give us, this 2 is basically square root of 2 times square root of 2, so it simplifies, and we are left with h is equal plus minus square root of 2. So this is minus square root of 2, and this is square root of 2. So we draw our intervals. It's h here. So, and this is e prime of h, and this is e of h. And okay, so now we need to go back to our function and try to put some more than negative square root of 2 numbers. So let's say minus 10, and oh god, there it is. So it's here. Well, you should actually calculate, you can't do this in your mind. So I hope you will believe me that once you do that, you get that, because I don't think that's very interesting to see how I just calculating numbers with calculator. Okay, so this will be negative, this will be positive, and this will be negative. So that means that the function is decreasing here, increasing here, and decreasing here. So what you get from this, that this is minimum and this is a maximum points. So we are asked only for a maximum point of a function. So our maximum point is a square root of 2. So now so if we put this number as square root of 2 in our original equation here, if we put it here, instead of h, we will get the maximum illuminance. Okay, a lightning in this point will be the best. Now let's look at our function. Our function looks like this time. So this is our minimum point. Okay, I wrote it like this. I put 7 here, so it would, instead of instead of this number, I put 7. I don't know if it's 7, I just did it for the sake of our graph being a bit nicer, because if I delete this, here's how our graph looks like. So it's hard to analyze it. Okay, so this function goes from very close to 0 to the end is decreasing to the point B. This is our minimum, and this is actually absolute minimum, and it is increasing from this point to the point C that we got. A square root of 2 is approximately 1.41, and it's, well, about here. Okay, so we get that this is not an only local maximum but an absolute maximum, because it starts decreasing and reaches 0 after some time, very close to 0. Now, when we are talking about physics problems and we are asked to calculate maximum and minimum values of some function, these functions are usually chosen to be, these maximums are chosen to be such that they wouldn't be local. They usually are absolute maximums and minimums. So yeah, that's about it, what I wanted to show you in this video. I completely understand that this example was a bit harder. It's taken from one Olympiad, physics Olympiad. It's not that hard to be considered Olympic level exercise, but you need to get this equation, this function. So I wouldn't say that it's very hard to get this, but well, you have to know some physics for that. Also, in my country, there is photometry isn't included in our school programs, so you have to study additionally to know how to solve this, and you need to find a derivative, and so you need pretty decent knowledge of math. And well, it was a bit harder, I would say, than the examples I showed you before. So yeah, that's about it. I left out one important concept about derivatives, so I'll create one more video on derivatives. And yeah, see you next time.